Imagine we are building a machine learning model for the airport security, for scanning baggages and classifying it as either a threat or safe. We have trained this model using hundreds of images, some showing dangerous items and others are completely safe. Now we'd like to do a trial run. We want to test our model to see how well it is performing on the new bags it has never seen before. But how do we measure its accuracy? How do we know if it's doing a good job or not? For each bags that goes through the scanner, the model can make one of the four possible decisions, the result outcomes. And these outcomes can be compared with the actual truth of the baggage to see if the model got it right or wrong. So let's walk through these four possible scenarios. Scenario 1: the bag actually contains a threat and the model correctly flags it as a threat. So that's a successful detection. This is called a true positive. And by the way, why do we call it as a positive? Think of it like a medical test. If someone tests positive for COVID, it means the virus is present. The things that we are looking for has been detected. In our case, things we are looking for is a threat. So a positive result means the model thinks a threat is present. And since the model was right in detecting it, we call it as a true positive. In scenario 2, the bag is completely safe and the model correctly says it is safe. So it's perfect. That's a true negative. True or false is the reality of the baggage, whether it is safe or not, and positive or negative is our model result, how it is detecting. So scenario 3, a bag is safe, but the model mistakenly says it's a threat. So this might delay the passengers unnecessarily. So this one is a false positive. It says positive for the threat, but it was wrong. And the final scenario is number 4, a bag is actually dangerous, but the model thinks it is safe. That's the worst case. And this is called a false negative. The model missed the threat. These four possible outcomes are what we track using something called a confusion matrix. Why the name confusion? Because it shows how often the model gets confused, where it mixes things up. It is not just about counting the right answers, it is about understanding the type of mistakes that the model makes. With this matrix, we can now say things like how often does the model correctly identify the threats? How often does it wrongly panic over a safe bag? And most importantly, how often does it miss a real threat? So the confusion matrix becomes like a report card, not just telling us if the model passed, but which question it got wrong and how serious those mistakes are. We can go beyond this. From the confusion matrix, we can calculate other powerful metrics like precision, recall, and the F1 score. These helps us in understanding things like how reliable the model is when it says a threat, how good it is in catching all the actual threats, and how to balance between the precision and the recall. Why to balance between? If these terms look new, I'll try to break down into separate videos for those different metrics that we can derive from these confusion matrix. So for now, we understood the purpose of the confusion matrix. It's a simple and a powerful tool that helps us in evaluating how the machine learning model performs. It shows the count of correct and incorrect predictions broken down as true positives, true negatives, false positives, and false negatives. So we can understand not just how often the model is right, but where it goes wrong.